Hi class, welcome back to the lesson 1, Introduction to Algebra. This is going to be lesson 1 of unit 2, which is just algebra and algebraic expressions. So in lesson 1, we're just going to do a little bit of intro. By the end of this lesson, you'll be able to know the definition of the word polynomial, monomial, binomial, trinomial, coefficient, and like terms. You'll know how to identify each of these in an equation as well. You'll know how to group and identify like terms. You'll know how to simplify polynomials using the rules to collect and simplify like terms. And you'll know how to simplify polynomials and to solve how to use simplification of polynomials to solve complex word problems. Some definitions of important concepts and important words that we use. This is important vocabulary. The first word that we're going to define is term. Right? So a term is a part of an algebraic expression. It's often expressed or separated from the rest of an expression by addition or subtraction symbols. So 45x cubed y, right? It's usually just a bunch of numbers and letters multiplied together. Right? So you would write it like that. You can have 2xy. You can have 2y squared x. When you add a plus or a minus, this is what separates them. So this is one term, this is another term. Okay? Right? A polynomial is an algebraic expression that comprises a sum or difference of monomials or terms. So another word for just a term like that is something we call a monomial, right? So you can have 3x, 4 and 8, so that's one term, 2 terms, 3 terms. You put all 3 terms together and now you have a polynomial. There's some special types of polynomials. A monomial is just an algebraic expression with only one term, so you have 3xy cubed, right? An algebraic expression with 2 terms is called a binomial, right? Bi just means 2. So you have 3x squared minus 5xy, that's term 1. This is term 2, right? An algebraic expression that contains 3 terms is called a trinomial, right? 1, 2, 3, because tri means 3, right? So that's just some special words that we use for polynomials. A coefficient is a factor by which a variable is multiplied, and it's usually placed before the variable. So for example, in the term 5x, right, the coefficient is 5. So the variable here is x. The coefficient is just the number in front of it, 5. So that is going to be our coefficient of a term. Like terms are algebraic terms that have the same variables, the same exponents, but their coefficients might be different. So if you look here, you have x squared y, and then you have x squared y. X squared y is the same as x squared y here. The only thing that's different is the 3 and the 12 over here. So something that has the same exponent and the same variables. If, for example, you had xy squared, that would not be a like term because the exponent isn't here, it's over here. So they have to be the same variables on the same exponent on the same variable. Xz, not a like term because it's not the same. X cubed y squared, not the same because the exponents are different, so on and so forth. Okay? So let's just circle the like terms in each of these groups. So let's look at this. So we have 4b, right? And then we have 4b squared. That's not the same because this squared is different. So we're going to cross that out, right? And then I have 4. There's no b, it's just 4. That's not the same. Negative 2b. Same variable, same exponent, just 1, right? So these two are the same. So try doing b by yourself and then come back and see if you know what they are. So I'm just pausing the video and now we're coming back. Perfect. So you have 5x squared y. Let's try to find if there's any other x squared y's here. X, y squared, no. X squared y. X squared, y squared, not. So those are the two. Okay, so you want to make sure that they have the same exponent on the same variable. Okay. So 3x didn't have the squared, and the y was squared, so that wasn't right. This was the y was squared, but it wasn't. So it says to identify the following as a monomial, binomial, or trinomial. Just a reminder, mono means 1, bi means 2, and tri means 3. So monomials are ones that have only one term. How many terms are here? 1, 2. So this is a binomial. So I'm going to go back in here and I'm going to say, all right, this is a binomial. I'm just going to circle it with a B. How many terms are here? You have 24x for y3. There's no plus, there's no minus. They're all multiplied together. So in this case, this is a monomial. There's only one term. Here you have one term separated by a subtraction sign is a second term. Separated by an addition sign is a third term. So this is a trinomial. This is only one term. There seems to be no multiplication, no subtraction, no addition. So this is a monomial. Right? So try doing these two on your own. Pause the video and just come back. Right? All right. Welcome back. So in this situation, you're going to have 6x squared b cubed plus, so you know that this is one term on its own. 9ab, this is our second term, right? So this is a binomial that has two terms. Same thing here, 5x plus, so that's 1, 2, 3. 3, this is a trinomial. Okay? As a rule, when we are simplifying polynomials, what we need to remember, you can only add or subtract like terms. So you can only add or subtract something that has the same exponent. So remember, like terms have the same exponents and the same variables. The only thing that's different is the coefficient. So the number at the front. Okay? So now it says simplify the following expression. So collect the like terms. So let's just go in here. We have a b to the power of 1, a b to the power of 1, and a b to the power of 1. That means that all of these are like terms. When you are simplifying expressions, you can just add or subtract the coefficients. So when collecting like terms, which means variables and exponents are the same, you can add / subtract just the coefficient, so the number at the front. So let's do that. So here I have 8 minus 3 plus 12. I'm going to leave the b as is. I'm going to do 8 minus 3 plus 12 is going to give me 17. So I'm left with 17b. And that is my answer. Okay? And that's how I'm going to do something like that. I'm going to go in. I'm going to check out the terms. I'm going to see which ones are the right terms. And then I'm going to move on and add them together. All right? So how about you try to do the next one by yourself? And the one thing I want to point out here, and I'm just going to write it down, if there is no coefficient, just like if there's no exponent, you're going to assume it's 1. Right? So we're just going to assume that this is a 1. So try doing that one by yourself using the same rules that we had already covered, right? Pause this video and then just come back and rewatch it. Alrighty? Okay. So, hopefully you came back. So you know that this is a cubed, a cubed, a cubed. So all of these are liked terms. So now I'm just going to add them together. I'm going to do 5 plus, so I'm going to leave the a cubed. I'm just going to go in and write my a cubed here. A cubed, because that's going to stay the same. And then I'm going to do 5 plus 1 minus 2. So 5 plus 1 we know is 6, minus 2 is 4. So it's 4a cubed. Okay? Now, if we're going to move on to this one, we need to first go in and see what are our like terms. So I have an m. So I'm going to go look. Do I have an m anywhere else? I do, right here. Negative 7. I'm just going to go back and fix that a little bit so that it looks nicer. Negative 7. So I'm going to say, okay, put the m down. 3 minus 7 is going to give me negative 4. Right? 3 minus 7 is negative 4. And then I'm going to go in and be like, okay, I have two n's. I have an n here and I have an n here. So it's positive 2 plus 10. And we're just going to leave the n. So 10 plus 2 is going to be positive 12. And that's going to be my solution. I can't do 3 plus 2 minus 7 plus 10 because they're not all like terms. Right? So make sure you collect the like terms and then put them beside each other if you want. I just do it all in one step. You could also have written in the step of 3m minus 7m and then plus 2n plus 10. And you can go ahead and do that. I don't do that, but it's completely up to you if you would like. Okay? So try doing D and E on your own. It's important for us to remember which ones are our like terms, right? And then make sure you collect them correctly. Okay? All right, so pause the video. Try to do D, E, F, G, H, I all on your own, right? Maybe leave I. We'll go over that one together. And then we will take this up together. All right, so welcome back. So I'm just going to take up for D with you, right? So here we have, I'm just going to go in and collect my like terms. I like to have different highlighters out for something like this because I find it easier to work with. So let's just put out 3 different highlighters. Perfect. Just going to move this over here. All right, so let's start off with my pink. With my pink, I'm just going to go highlight all the ones that have just x as a variable. So this is y squared, and then I have another x over here. So I'm going to put my first one as an x. I know that my first answer is going to be something x. Then I'm going to go look, okay, I have a y squared. Let's go find all my y squares. There's a y squared, there's another y squared right here. That's a y, so I'm not going to put that in. So I know I'm going to have something y squared. And then I'm going to go look and be like, all right, what's my last one? Just a negative y, so I'm going to have something y. Okay? Since it's just negative y, I'm going to just leave it in as negative y. I'm not collecting it with anything. Now, I'm going to go back here and I'm going to say, okay, I have a negative 4x. So negative 4. And then I have a positive 1x. So it's negative 4 plus 1. So that's going to turn into negative 3x. Oops, sorry, no. I have negative 4 plus 1. I'm right, it is negative 3. negative 3x. Right? My y squared is going to be 5 minus 3. 5 minus 3, I know, is just 2. So if you want, you can write that in as this. Right? You can write it in as 5 minus 3y squared. Right? So 5 minus 3 is going to give me 2. So plus 2y squared. Minus y because there was nothing else left to collect it with. Now, I've collected this term. I've collected this term, and I've collected this term. That is my most simplified answer. Negative 3x plus 2x minus y. Okay? So if you just take it step by step, collect step by step, that's the best way to go about it. So how about here? So I'm going to go in, I'm going to use my pink highlighter. I'm going to say, okay, I'm going to find all my AB squares. That's a squared b, so that's not right. This one, negative 7, is ab squared. And then that's also a squared plus b. So I'm going to collect that one as well. Right, so in pink, I'm going to do 4ab squared minus 7ab squared. And then in blue, I'm going to do plus a squared b plus 1a squared b, because I know that's a 1 in front of this. It's always invisible. So then I'm just going to do, okay, 4 minus 7 is going to give me, right, 4 minus 7 is going to give me negative 3ab squared. And then I have positive 8 plus 1 is going to give me positive 9a squared b. You could also have written this as 9a squared b minus 3ab squared. It means the same thing, but that's just how I decided to write it up here. Okay? Moving on. So, when you're given something like this, right? And we'll learn more about this when we learn about what we call the distributive property, right? Here you have 2x squared minus 5x plus 6. And because you have a minus sign and plus sign here, you can just drop the brackets. So I'm going to have x squared plus x plus 4. Right? Because you're going to multiply everything inside of this bracket by positive 1. But that's fine because positive 1 times everything inside the bracket is just the same number. Okay? So, now that you have that, you can just go in and collect your like terms. So I'm going to start off with the pink. I'm going to say, okay, I have an x squared here. That's an x. So that's not it. That's not, there's no variable there. And I have another x squared here. So I'm just going to go and write it. I'm going to write it as 2x squared. And that's a plus x. Right? So you always take the sign from in front of the variable, plus x squared. Now I'm going to go, okay, let me find the minus 5. So, right, I'm taking the sign from in front, 5x, and then positive x. So I'm going to go write that in. Minus 5x, positive x. And then, last but not least, I'm going to say, okay, that's a positive 6 and that's a positive 4. They both don't have variables. They're just coefficients. So I'm going to add that in as well. So plus 6 plus 4. Now I'm just going to go and simplify this. We're going to do 2 plus 1. That's going to leave me with 3x squared. I'm going to go in and do negative 5 plus 1 is going to leave me with negative 4x. Right? And then I'm going to do positive 6 plus 4 plus 10. And that is the most simplified version because now everything only has one number in front of it. Cool. Moving on. So now here we have 2 over 3m minus 1 over 2n plus 5 over 6m minus 3 over 4n. And to the naked eye, this looks really, really confusing. And the only reason it looks confusing is because I put fractions in. let's just go deal with this as not fractions, right? The same way. Let's just separate it and collect our like terms first. So here we have 2 over 3m. So I'm going to go try to find anything else that has just an m. This is an n. This is just an m, so that works. And it's a positive. And that's an n. So I'm just going to go back and write these in pink. I'm going to say, okay, 2 over 3m plus, because that's a positive, 5 over 6, 5 over 6m. Then I'm going to look for, okay, I have a negative 1 over 2n, so I'm just going to go write that in. Negative 1 over 2n plus, or minus, 3 over 4n. Right? Now I have my m's and my n's. Lucky for me, I can now reduce this so that I can make 2 over 3 plus 5 over 6. So let's go over and do that over here. How can I do 2 over 3 plus 5 over 6? I can just change my 2 over 3 to over 6. So from 3 to 6, it's multiplied by 2. From 2 to 2 times 2 is 4. So that's the equivalent fraction, plus 5 over 6, right? And I'm left with 4 plus 5, which is just going to give me 9 over 6, which I can reduce to 3 over 2. I'm going to reduce that to 3 over 2. And then I have here negative 1 over 2. So I'm just going to add this over here, negative 1 over 2 minus 3 over 4. And I can change the 1 over 2 to over 4 by multiplying both the top and the bottom by 2. So I have negative 2 minus 3 over 4. And then I'm just going to do negative 2 minus 3. It's going to give me negative 5 over 4. Right, so negative 5 over 4, and the variable that was after was n, and that is my answer, because I can't simplify this any further. I can't collect any like terms. That's just my final answer. Cool? Alrighty. So let's go over to h here now, right? So I have, I'm just going to go use that pen, yeah. I'm going to use my blue pen. So I have 4n plus minus 3m minus negative 2n plus negative 7n. Normally I would say just go and do all the collecting of like terms, but before you even do that, simplify these signs. Make them so they're only one. This is a really confusing equation to work with. So let's do 4n plus and minus give us minus 3m. Minus and minus give us a plus, plus 2n. Plus and minus give us negative. And now let's go collect our like terms. So we have our n's. So we have 4n and positive 2n. So let's just put those together. And then you have our m's. You have negative 3 and negative 7. So I'm just going to go put that in. Negative 3m, negative 7n. Right? And now let's just start adding and subtracting these. So 4n plus 2n, 4 plus 2 is 6, and the n stays the same. 3m minus 7, oh, that should be 3. Oh, look at that, I made a mistake. This is an n. Why did I highlight it in green? It should be blue. Right? So you have 4 plus 2 minus 7n. Minus 3m, and that's why you have to be careful. You have to make sure you're collecting all the right terms. So you have 4 plus 2 minus 7, which leaves you with negative 1, right? Negative 1, so I'm just going to write it as negative n. And then the 3 doesn't have a partner, so we're just going to leave it as 3m. Okay, and that's my answer. You could write the negative 1 here. I won't dock numerics, but some teachers might for form. So it's probably just the best habit to get into writing negative n, because that's proper form. So it says here, determine the simplified expression for perimeter. So the types of questions that we've been doing so far, all of these, are straight knowledge questions. You're taking what you learned, now you're just applying that knowledge to a straight problem. This question, this perimeter question, is more of an application-based question, right? This is you're taking it and you're applying it to a real world problem. So let's do that together. And you need to think a little bit outside the box. It says simplified expression for perimeter. First things first, I need to figure out what perimeter is, right? So for those of you who don't remember, perimeter is when you take all of these sides, the length of all of these sides, right? And add them together. And that'll give you the perimeter. So let's do that. So the length of side, the length of side 1, right? Or let's do A, B, C. So the length of side A plus the length of side B plus the length of side C. Okay? And we're going to do P is equal to, side A is 3x, and whenever you're substituting, you're always going to substitute with brackets, plus B is 4x, plus C is 6x plus 3. Now, because these are all positives, it's safe for us to just drop the brackets. If those were negatives, you can't drop the brackets, and I'll show you how to do that, right? But because those are all positives, we can just drop the brackets. So I can say P is equal to, I don't know why my P keeps autocorrecting, 3x plus 1 plus 4x plus 6 plus 3. And now I can just go in and collect my like terms. So I'm going to use my pink to do my x's, positive 3, positive 4, positive 6. So I'm just going to go write that in pink. So 3x plus 4x plus 6x. And then I'm left over with positive 1, positive 3. So I'm just going to say, all right, plus 1, plus 3. And now I'm just going to simplify, right? So I have all of my x's. I can just add their coefficients. So I'm going to do 3 plus 4 plus 6. 3 plus 4 is going to give me 10 plus, 3 plus 4 is going to give me 7, plus 6 is going to give me 13, right? And then I have 1 plus 3, which is just going to give me 4. So my answer is 13x plus 4. Alrighty. So this is combining our knowledge from last unit and this unit together, right? So math is one of those things that just build on each other. So we need to make sure that we know how they're building on each other. We learned how to substitute last unit, and now we're going to use that and simplify, then evaluate, right? So if I have something like this, I'm going to be given it to me, and I'm going to be given this on a test, and it's going to say simplify. So first, let's collect all the like terms, make it super easy to work with, and then go in and plug that in. Okay? So let's do this. So you have 3b minus 2a plus 10b minus a plus 5. So let's go in and find our first variable, which is a b. And then let's go find our second b. It's positive 10b. And I'm just going to go write that down. I'm going to say, okay, 3b plus 10b. Right? Done all of B's. I'm good to go. Let's move on to the A's. So I have negative 2a minus a. Right? So I'm just going to go plug it in for now. I'm just going to write it down. 2a minus a. And then the last one I have is positive 5. Positive 5 doesn't seem to have anything else, so I'm just going to leave it as it is. Now I'm going to go collect my like terms. I have 3b and 10b, so I'm going to add the coefficients, leave the b alone. Add the coefficients. 3 plus 10 is 13. Now I'm going to say, okay, I have negative 2 minus a, so that's negative 2 minus 1, right, which is negative 3. And I'm going to leave the a alone. There's nothing to add or subtract 5 to, so I'm just going to leave it as is. So 13b minus 5a plus 5 is my answer. Okay? That is the most simplified expression. Now what I'm going to do is I know that a is equal to negative 2. So I'm going to say, okay, b minus 3a plus 5. I'm just going to go substitute my stuff in. So I'm going to say, okay, So I know b is equal to 4, so 13 multiplied by 4, and always make sure it's in brackets, minus 3 negative 2 plus 5, right? So I'm going to do 13 times 4, which is 52, minus 3 times negative 2 is negative 6, plus 5. Now I'm going to take this negative and this negative, it's going to become a positive. Positive 6 plus 5. 52 plus 6 plus 5, so 52 plus 6 plus 5 is equal to 63. And that is my answer. Okay? And then we're just going to move on to B. So here we have 2a squared. I'm just going to go back here. I have 2a squared. So I'm going to see if I can find another a squared. There's a negative a squared there. So I'm just going to go and put that in pink. So I'm going to say, okay, I have 2a squared, and that's a minus a squared. And then I'm going to find my b. It's a negative 4b plus 9b, right? Negative 4b plus 9b. So I'm going to do 2 minus 1 is going to give me just 1. So I'm going to leave it as a squared. Negative 4, right, plus 9 is going to give me positive 5. So I'm just going to go put that in. Positive 5b, right? And I'm just going to go substitute my a and my b in. So I know that my a is negative 2, so I'm going to plug that in. Negative 2 squared. And then plus 5 times 4, right? 5 times 4. I know what I went. Sorry. I'm just going to go back and fix this mistake. This shouldn't be, this should be a 4, right? Because that was, nope, never mind. I was wrong. Ignore that. I was right the first time, right? So here I have a squared, which is going to be negative 2, because that's what a is. B is 4, so negative 2 squared is just going to be 4. 5 times 4 is going to be 20, so plus 20. 4 plus 20 is 24. Okay, and that's my answer. And that's how I would solve that. Okay, so that's when you put together those two terms. There's a really good resource here. It's called mathisfun.com/algebra/like terms. There's a quiz at the bottom of this page that's actually really helpful. I would highly recommend going and testing it out. If you go into your lesson that I've posted for this, there's actually a hyperlink for that. So you can just click on that hyperlink and it'll take you straight to our to that fun site. It's not mandatory, but you might like it. A lot of students often struggle with this, so I really recommend it. It'll help you understand what a like term is, and it's very interactive. So if you're still not understanding and you're really struggling with this, this is a really good resource. Okay?